Hello everybody, I would like to welcome you to this course on electrochemical impedance spectroscopy. So, this course is targeted towards science and engineering graduate students working in the area of electrochemistry. It is also intended to be useful to the engineers and scientists in certain areas such as batteries, fuel cells, working in corrosion, electroplating, biosensors, supercapacitors, anything which is electrochemistry related. I hope it will be beneficial to you. Okay. In electrochemistry there are many techniques available. This is one of the many techniques. It is a fairly complex technique, it is very versatile. You can get information at a level much deeper than what you can get with many other techniques, but this also means that you have to understand this technique well, so that you can acquire the data correctly. You can run the experiments correctly and analyze and interpret the data correctly. Now, here is the course outline. First 1 week we would spend on introduction to electrochemistry and introduction to impedance spectroscopy. Next 1 more week on experimental details, what settings one should use, what are the choices available, etc. And then 1 week on data validation. In impedance spectroscopy you can validate the data. This is more than what you would do for normal data. And then analysis, there are different types of analysis. 1 week we would spend on analyzing using electrical circuits. It is basically an analogy saying this data can arise from an electrical circuit with so many resistors, so many capacitors combined like this, and therefore we can interpret it and say physically this is what it means. And a better level of analysis can be achieved by using mechanistic analysis, saying this reaction would give rise to this impedance spectrum. That is little more involved, and we would spend about 3 weeks in this. And those analysis would assume that the solution is well mixed, mass transfer is rapid, but if mass transfer is not rapid, what would we see in the impedance spectrum? We would spend a week on that. We also assume previously that the electrodes are simple electrodes, and if the electrodes are porous, if the electrodes are rough, we would see a slightly different behavior, and we would spend a week on that. What if there is a film on top of this electrode? Okay, that is described by a model called point defect model and few applications. Okay. We will spend a week on that, and the last 2 weeks I want to spend on a technique called nonlinear EIS. It is an extension of this EIS technique, and that is one of the newer fields. So, a couple of weeks giving you theoretical background as well as some hints on the experimental aspects. Now, at the end of the course, what do you expect to achieve? What is the benefit to the audience? What can you do at the end of the course that you can't do now? What can you do better? I hope or I intend that at the end of this course that you would be getting sufficient background and practical hints, okay, do's and don'ts for planning EIS experiments, for doing the experiments, and in analyzing the data. You will actually have to do the experiments with a specific equipment to really learn all the experimental aspects. Okay. You will not get all that experience by just watching these videos. Once you get EIS data, whether you get it or whether you get from some other source, you will know how to validate the data. Okay. And when that is validated, you will also know how to use electrical circuits or equivalent circuit analogy and fit the data and interpret the data. I hope that you would also be able to get an overall view, a top level view of what mechanism might give rise to this spectrum. So, a limited level of mechanistic interpretation. In order to be able to do a detailed mechanistic interpretation, you will have to watch these videos, and in addition you will have to write some code. So, you will have to make extra effort to be able to do a detailed mechanistic analysis. And similarly, in nonlinear EIS, I hope that you will be able to understand and interpret the data to some level at the end of this course. And with additional efforts, of course, you should be able to do detailed analysis of the data. So, in summary, I hope that you will be able to get a clearer understanding of any system, any electrochemical system that you investigate using this EAS technique.